class. So we are going to start getting into what Algebra 1 is usually known as, okay? And that is graphing, that is lines, things called functions. I keep expecting this to move whenever I move this around, but because the camera's on it, it's just not. A little bit of inside there. Functions, graphs, equations. You already know a little bit about equations. So what I've got here, and what you have in front of you, is a little assignment. And we're going to talk about what's called linear correlation. Okay? Think about those two words. Linear correlation. What might that mean? Lines. What else, Aiden? Lines that correspond with each other. I really like that one. Okay, so lines. Corresponding lines.
Sure.
What else? Positive and negative lines. I'll put an asterisk next to that one.
That's crazy.
What else? Yes, Aiden.
I'm not understanding about this one,
Patterns. Put an asterisk next to that one. So think about these. Think about those words.
Aiden? Everyone, you need to be listening. Voice is off.
The other thing is I shouldn't see phones out either. Put your phones in your pockets or your backpacks. Same thing for Chromebooks. Chromebooks need to be in your backpacks. We're not using those right now. So think some more. I've had probably 3 or 4 people answer. Linear correlation. Let's hear a couple more. What might that mean? Say that again. Kind of. I'll ask her.
Oh.
Someone besides Aiden or Olivia or Britannia. Don't be waiting on that rock for somebody to come pick you up. Remember that? Scarlett. Growth. That's another big one. Trust me, it's just inconsistency in my handwriting. Aiden, I see you, but I'm trying to get some other people to use their brains to start thinking too.
Maybe like vertical and horizontal.
Vertical versus horizontal. All right, so in front of you, keep all these in mind. In front of you, you've got, I'm going to try and make this taller.
No, it makes us look like we're falling.
It really does. It's like, Loki, I've been falling for 30 minutes. So I have a graph here, all right, and we've got an axis right here that says that's age, all right, that's how old you are right here, and it's increasing as it goes up. And then your height, it's increasing as it goes
Down.
that way. Okay. So we got up and down for age, and then side to side for height. It's kind of weird. Your height really doesn't do that. So that's a good point, Olivia. So then I have a bunch of people here. Okay. Each point represents one of these people. Okay. We don't have to do any numbers or any proportions or any kind of math for this. We are just looking at the relationship between these people pictured here, their age, and their height. So we'll start with an easy one.
Kathy.
Who's this one?
Her, the young girl.
Kathy, the little
The
girl,
baby.
right? All right, so We're going to label each point. And I should just do this with my pen. So this one's going to be Kathy.
So we put the name over the dot.
Yeah.
Oh,
We're just labeling the dots. How about...
Hold on, Mr. Vaughn. Why is that one Kathy?
Because
Oh,
she's
good
the
question.
smallest.
She's the smallest
And the youngest.
Okay. The youngest, right? Because you've got age up here. This is how old you are. The older you are, the higher up you are on this graph, right?
Yeah.
And then your height, the taller you are, the further you're over here, right? So if that is true, then who is this?
That's gonna be
The one-
Denny.
That's good. No, that's Agatha. All the way up on the top right.
Erica.
Ernie's at Ernie.
This is Dennis.
Ernie?
Is he the tallest in the group?
No,
No.
Ernie.
Agatha.
Ernie.
Is Ernie the oldest in the group?
No.
Ernie is not the oldest in the group.
No, it's the girl on the left, the far left, first one.
Right over here?
Yeah.
Yes, it's
Agatha?
Yeah.
Why?
Because she's the tallest and she's one of the oldest.
There we go. Okay. You guys see the connection?
Yes.
Alright. So we got Agatha over here. So then who's this?
Who? What?
Dennis.
Denny.
Ernie.
Why is it Dennis?
Dennis is a
He's the oldest and he's short, but he's like the oldest.
Right. So just like what Britannia just said, Dennis is not the tallest, right? But he's one of the oldest. So he's not going to be all the way up here. He's going to be all the way over here.
What's that axis?
The age axis. He's not going to be all the way up on the top.
He should be.
Yeah, you should.
Yeah, he should.
Oh, yeah, you're right.
Yeah.
I got the two backwards.
Yeah, you say
I was doing what you were doing. I was thinking this is height and this is a good example to pay attention to your labels. In fact, I'm going to start that so I know I need to pay attention. Jeez. You know what's really funny is I looked over this before I. Yes.
Really?
Yes.
And you still messed up.
Yes. Thank you. Have some grace on me, guys.
Yes.
So if this is age, though, let's think about this. If this is age and this is height, this isn't going to be Dennis then, because height is this way, age is this way.
That's gonna be.
We already have Agatha.
Barbara.
What is the pattern? What is the relationship with that
I
dot?
don't know.
In
The
terms of
height.
age and height.
The height and the age.
What is the height? The height is big, high, tall, or short?
Tall.
So.
And then
So
we
it
can
is
say
gonna
the
be
tall
Ernie.
is. Does that dot have to be the tallest?
No.
Taller.
But what about the age? Is it the oldest?
No.
But it does need to be one of the taller ones.
Yeah.
Think about the relationship, guys. One of the things that I've said when I'm not trying to completely take over, but I also want you guys to think about. We talked about this with proportions. You have to understand that there's a connection between the two ideas. You can't think of one without the other. As we go through this entire unit, they are paired. Remember that word. They are paired together. You have to pair the two ideas together. So that dot that is circled, Mr. Bond, point to it for me. That dot that is circled, what is the relationship? That person is
Older.
Tall.
And he's tall.
but he's not
Old.
old.
So he's like middle. Middle.
Good.
Could be Ernie.
Wouldn't Kathy be the baby Gavin?
Ain't no way.
Wait.
Yes.
Baby Gavin would be the left one, wouldn't he?
Oh, I didn't even notice that.
Or you did Baby Gavin.
So then,
That would be.
so here, hold up. Let's focus on this dot first, and then we can go back and correct this. Okay. So, who would this be? Tallest, right? Because they're the most. According to the graph, they're the tallest person here, right? Okay, so it's going to be Ernie, right? Because he's the tallest, but he's not the oldest. He's fairly young, right? Okay. So, we just noticed something. We've got baby Gavin right here. All right. So thinking about baby Gavin, where would he be? He'd be the first one because he's the youngest and he's the smallest, right?
But wait, he's with Frida.
Don't overthink that one. We'll stick with this. I like where you're. So then, if baby Gavin's here,
She would be the next one.
who's going to be the next one?
Kathy.
Okay, and why Kathy?
Because she's the second.
mama.
No, Kathy would be the second dot because of her height and her age.
Right. Kathy's not the shortest, right?
No, baby Gavin is.
Baby Gavin's the shortest, but she's not the youngest either. But we know she's younger than Dennis, Ernie, and everybody else other than the baby. So we can say that this dot is Kathy.
Yeah.
Okay. Now I love you guys' participation, but I'm going to try and get everybody else in. So I'm going to put you guys on pause for a second. Okay. Like I said, I'm loving it. I got to get them time to think too. The rest of you, we've got 3 dots left. 3 dots left. Who's going to be this?
Dennis.
And why Dennis?
Because he's the oldest.
He's the oldest. So he's going to be, but why is he not over here? Why is this Agatha then? She's taller. Does everybody see what just happened?
No.
We just kind of ruled out Agatha because we know she's the tallest, so she's going to be all the way over here, and she's also pretty old. She's one of the oldest, so she's going to be towards the top. And we know Dennis is shorter than Agatha, right? So if this is the tallest over here, this way is going shorter, right?
Right, yeah.
So then that's why it's Dennis.
I just
Mr. McKinney, do you think I'm being clear enough with this? Okay.
So if you think about it, if you go this way to the left, the height gets smaller. Then if you go to the right, the height gets bigger.
So think about it this way. Height is getting bigger as you go up. Go this way. Age is getting bigger if you're going that way.
And if you're getting smaller, you go.
So here, I'll say 0. 0. Who's gonna be?
What?
Who's gonna be this middle dot?
Barbara. I think that's what her name is.
Why Barbara?
Because she's shorter than Brenda.
Because she's shorter than who? So she's shorter than Freda, so she's going to be more this way, right?
Yeah,
Instead of all the way out here. And what else?
her age is younger.
She's younger.
So she'd be the next. Oh, sorry. I keep forgetting her own class.
I love the enthusiasm. And now we know the last one is Olivia. You can say it.
What was the last one?
Frida.
Oh yeah, Frida. That's what I was gonna say Barbara, but then like.
No. What?
So guys, this is important because going forward, especially when we get into functions and we get into graphing functions, that's basically what this is, except we're using numbers instead. So you got the lowest number over here and the highest number in this direction. That's just something to keep in mind. There's a proportion between height or age here in this one and height. Does everybody see the connection?
Yes.
Okay. Let's try another one.
Oh. Which side though? This side.
All right. So graphs can be used to represent kind of anything, right? Does anybody remember what kind of graphs are there? Think about it.
There's graphs for like
Aiden?
Pie graph. That's a pie chart. Sorry, line graph.
Pie graph, pie chart, yeah. Line graph. What else, Britannia?
charts of different data.
Right. So what, for example? Bar graphs, pictographs. The one we're focusing on a lot is a linear graph. Okay. So what two things are being, if we think about proportions, what two things are being compared here?
Height to time.
Time and height. Okay, even you could write it off to the side. So this is by the way, this is a cannonball shot from a cannon. Okay, so this is the time, right? So obviously the time doesn't start until after the cannonball is shot. So here it is, it's going up, and then it comes down, and that's where it stops. It blows up, whatever. It stops moving, it stops existing. Some of them do. Some war area ones do.
Exactly.
Well, yeah. I'm gonna add it.
Because they got like a fuse. So for question A, when time is 0, so time is 0 is over here, right?
Yeah.
When time is 0, why is the height not 0?
Because it didn't start at 0.
Exactly.
Because the cannon shot up, so it's not necessarily 0.
Meaning, rephrase that. You're on the right track.
So when the cannon is shot up, so the height is like upwards. So it's not like it started at a sideways point where it's just going forward. So it's up.
So what it sounds like you're trying to say is cannon's pointing straight up. The cannonball isn't necessarily on the ground.
Yes.
Right.
It can't
So-
go that far back, then it's gonna tip over.
Well, yeah, but I mean, so more like this or this. Because remember, we're looking at height, not the angle that it's flying at. Okay? So even if it's angled like this, even if the cannon were to be angled like that, and the ball is in here,
Mhm.
with all the stuff behind it,
Mhm.
is this on the ground?
Yes.
The ball.
No.
The ball, no, the wheel, yeah.
Right. And the ball is what we're looking at. Pay attention. Even I made the same mistake last time where I wasn't paying attention to the height and the age and got the two mixed up. So pay close attention to the detail they give you for the reason. So yeah, clearly it's not on the ground. So even if it were shot and it goes like this, okay, that height is still going to change, and your height is still different from when it was in the cannon. Does that make sense? So go ahead and write that in.
So don't fill it in. Make them fill it in. No, and then you fill it in.
Come back in and fill it in later.
They need to get to the point where they're not copying down what you write, but actually thinking about it and putting it into their own words.
So do that. Put it in your own words. Like what Mr. McKinney said.
And we're going to come around and check.
So if you already blew through this and have that written down, try and answer question B. Don't say it out loud. In real life situations, why are we often restricted to a positive value?
Yeah.
I don't know how that got moved, but yeah. So it is listed. So in real life situations, why are we restricted to a positive value? We seem more positive on all that.
That's what I use this for like when I'm using snow. Because I tied it too tight and now I can get it out. I don't even know. Today? Yeah. So now I can get it untied. So I kept trying to pull it out and fix it, but it wouldn't come along.
Pretty much all day. We go watch a
If you're done with A, you can go ahead and try B.
I don't know what I mean
Yeah,
by
that doesn't
B.
make sense.
You think about it.
I am. I'm
So-
still thinking about it.
So for those of you who are confused about B, it's a little wordy, right? But when we think back to word problems, when we were when we were working with word problems, what was a key thing that I always told you guys? What do we look for?
Oh, keywords.
Keywords. So what are some keywords that you guys can find in there?
Real life situations, often restricted to positive values.
That's not
Okay.
all. It's not all positive.
So underline them, mark them, star them, highlight them. And you don't have to shout them out. Just underline them, highlight them, star them, put a heart on them or whatever. Mark the stuff that's important so that we can answer questions.
That's a cute part. Wait, what? I don't know. I don't have positive. I'll put it on real life.
Good.
See, I told you, real life. Restricted, often
Why
positive values. I told you.
Think about it. What does a positive value look like?
Mr. Bob, what'd you get from Sonic?
What now?
What'd you get from Sonic?
Oh, Miss Keezer got me that.
Ooh. Yeah, let me. I want Sonic. Yeah, let me.
And I didn't get one. How dare you? That's not giving me a
At least I get McDonald's tomorrow. McDonald's.
Oh, duh. You just said McDonald's too. I didn't say where.
I'm getting myself Chick-fil-A for dinner today.
Really? What do you like from Chick-fil-A? Like, what do you just get?
I usually get the grilled chicken.
So in real life situation, think about this. This is what I like to
What's my favorite thing?
My favorite thing is the nuggets.
The nuggets and the chicken strips are good.
Especially with the Chick-fil-A sauce.
What was that?
I just have so much that you dip in.
Why can't we have Right, we can't go back.
Nuggets and the Chick-fil-A
We can
sauce.
only go
Because
forward.
we sit there and this guy's like,
Okay. We want to-
slow motion. So much. Now I want Chick-fil-A. Let's go. How dare you? I'm gonna get a spot after school and have to drive me to Chick-fil-A. I'm pop out of the truck and like, hey, why don't you get me Chick-fil-A? So like, no! Like, so I drive this way for no reason. Not the second question.
Why don't I see a line going down?
No. Actually, yes, you can. Actually, yeah, let your car just tell me. Because that's not how it works. That's not how gravity works. You have to be like, oh, this person's negative. I'm gonna throw them down their negative ways.
Physics.
So can you go back in time?
Because there's no technical thing that a speed limit that's below 0.
Yeah, it's negative 0. Actually, I think there is a negative 0.
It's good. It's also good. I'm sorry, I misunderstood.
Not when driving a car. It's not when
Why is this
Real life situation.
I wish.
Oh yeah,
The wolf.
That's how everything was made.
Exactly.
Just right there. My mom said
That's my mom is actually.
Most of the time, it's positive. Because negative is going back.
because Earth is made positive.
But that's because that's how the world goes.
More than that.
More than the first and second.
Okay.
I want you to be a little bit more detailed. Think about what does this right here represent? Negative what?
Numbers.
In this
Negative height.
Negative time.
Negative time. This is time, right?
Yeah.
So this would be negative time. What does that mean in real life?
Go back in time.
Can we go back in time?
Maybe.
Sometimes I wish I could.
If I can go to time machine by time,
Right? So why don't we have the negative value represented in time?
Go back in time.
Go back. Nice and water.
I'm almost done.
Cold. It's cold. I'm so lunch.
I said because that's how the world's built.
I'm built like that. Lifetime business makes me feel like a noodle. Every time I leave, we have to do the sheets, the treadmill, and then after that, we're done.
Look at her answer. Look at my answer. Her answer's not as good. That's how the world's built.
Can't go back in time. Can't go back in time. What if? Is that possible?
No.
So, not thinking about time. Don't think about time.
Lanny just said think about time.
Right, but I'm saying he's not wrong. Now let's think about height. Maybe I should have gone here.
You can probably go ahead and do number 2.
Can that happen?
Yes.
Yes. Why that?
Because if you go so basically if there's negative time, there's not negative time, but if you go down negative height, you go down a height.
You go underground.
Yeah.
So like the cannonball comes down, makes a dent.
Yeah, or like, what are those things called? Those things up in space? Yeah, meteor, it comes down, it'll crash down to the ground. It goes down into the dirt.
I like it.
Astronaut? What are those things in space?
Alright, finish it up.
Very good.
That was awesome. right. So, why? Okay. We're moving on to number 2, right?
Yes. Mr. Fly.
I thought we were going over it again. I was like,
I thought we were going to space.
so how about this one? Why does this graph, and this is kind of why I touched on this with you guys, why is this graph got a negative number in it though?
Because it does.
Carlos?
You gotta spend money to make money.
Okay, elaborate.
She had to buy the lemons, water, and sugar to make the lemonade.
Right.
She had to make money until she made that profit back, until she could start making profit.
So, and explain it in terms of the graph. So, how does she make money then?
She sold lemonade.
A job.
Right. So she spent the money, and that's obviously not profit. That's the opposite of profit. And then she had to start selling, and as she started to sell, it eventually paid for itself, and then she made more profit. Right?
She's not in the negative.
Can we have something like this?
No.
I mean,
Well, explain that to me. I don't understand.
Because they
We've got a
have to
negative here. Why can't we have a negative?
Well, because you have to be able to sell something.
You can't just be like, oh, this is negative sales.
No, it's because you can't not just sell nothing.
Well, I
You
am.
get money
Yes, you
from
can.
it.
I can sell money.
Okay, there we go. That's the key word.
I was finishing that.
I mean, I could give it away and get nothing, but in terms of the graph, you can't negative sell something. That's why this side over here doesn't work. Okay?
It's kind of dead.
So you can even label this.
Can't happen.
Maybe write that a little bit more clearly.
Alright, so
That's all I can see.
I see his hand.
Just,
Negative.
this is also kind of delayed, so you don't see everything.
Negative selling can't happen.
But we can. What if something happens? What if she gets sick and this happens?
Sucks to suck.
So, well, no, that doesn't mean she's dead. That's not what the graph is saying. Oh, debt. That's what you said. This is good.
I said dead.
Good answer. Good answer.
That's
Right.
really.
Yes. Thank you. But good because why does this mean debt?
Because it's negative.
Because it's negative. And
She
we know
has
it's,
no more money.
well, it's negative, and we know it's negative. Why?
It's because she has no more money.
Because she's spending it on more so like.
Where's
She's
the
not
line at?
selling it.
What, yeah, so what we're saying, there's reasons, and those are good reasons. But what I'm asking is, I'm saying, why is this negative? Looking at the graph, don't think of a reason why she went into debt, but why do we know this is negative?
It's under the grind.
It goes under the zero. Okay, it goes under the axis.
Look at me go, guys.
So under A, why does the graph show values below zero?
Because
In your own words, write it. Don't shout it out. Write it in your own words. Okay. And we already kind of talked about this. What does it mean when the graph crosses the axis?
Back into positive money.
Write it in your own words.
I know I did.
literally what I said. I give the answer. Do you want us to move on to the next one if we're done with the first one?
Yeah, if you want to. You guys have it.
We got to label our words. Or context.
So, selling is present tense.
Yeah. 8 o'clock.
That probably wouldn't work out right. We come back here. I was thinking that was the
What is the meaning of the point graph? That one word that you said.
Pen is like stuck. Oh, there. And when it come out for a second, whoa! You like OG? Okay, we're being.
This is
I know where Jim said.
crossing over from where they lost.
That's a little bunny rabbit. I'm gonna go to Walmart tonight and buy just the ones I'm for.
At what point did you get? That point did you get back?
I'm not gonna be here.
Well, I won't either.
I will be in Topeka for a swim.
You actually have.
I coach swimming.
Since when?
Since always, we talked about it last time.
Since I was 19 years old. So I've been swimming since I was 3. I still swim. I still compete. But since I'm not in high school anymore, I compete but I've been swimming since I was 3. Swam club in high school all the way up until I graduated. And then I got hired by one of the coaches, my assistant coach. So I've been coaching for 5 years. This will be my 5th.
I won't be here either.
Why? Are you? What movie?
Migration. You get the theater right just tonight.
Yeah, they
They
get
make McDonald's for lunch after.
Oh, okay. I was trying to do like a portrait screen thing where they.
that would be
Don't
fun.
do it at AMC. AMC's food is terrible.
That's what we're doing. We're AMC.
Well, AMC the movies is fine, but if they like review your food, they're like kitchen, like their chicken business.
I remember I had some like hot wings, bro. That was like some Taco Bell. It was crazy. I had to use the toilet. It was crazy. It was crazy. It was wild.
What is the meaning of the famous grass crops to the horizontal axis?
Do that same tactic. That's what it's
Horizontal sideways.
We're going to learn about that.
Horizontal is
So, I want you to think about version of graph.
open.
Alright, real quick, last thing. Last thing. I also just realized I stuck my gas in the pocket. There you go. Alright. So, this is, once you have finished and I've checked everything in number 2, you are free to complete the rest of the packet if you have not already started. You are free to complete the rest of the packet. It's due at the end of the hour, so you've got 42 minutes to do it. Again, just like we've been doing, you are welcome to chat amongst your neighbor, but you need to make sure you guys are thinking and not just copying stuff down. Alright? If you're just copying stuff down, then you're not learning anything. You're just writing what you see. Okay? The answers to these questions, even though some of them might be vague, need to be in your own words. So when I go through and I grade them and I see somebody writing exactly word for word in the same spot, then I'm going to know that somebody's copying. Okay? And you won't get credit for that. So write in your own words what is going on, what you believe is happening in the graph. Ask Mr. McKinney and I if you have questions, or Ms. Boleen. Alright? Until the end of the hour you have to finish this, okay? Alright, ready? Great. Ready, Greg? Yep. My ceramics teacher, who was actually my cross country he would say, all right, everybody, ready, break. And then we go and we do our thing. And
we keep this for a later day, or
Jack. Yeah, Jack. He needs a fact check you like I had to. Yeah. Cookie?
Okay. Is it turning on? The temperature is rising over time. What does that tell you?
that is preheating, so it's kind of like slowly starting.
It doesn't actually go back to
He's making you think.
And just bring it somewhere.
You.
Right? Yeah, good.
Dad.
I'm gonna, Mr. Vaughn, I'm gonna take Kate and we're gonna go across the hall.
Oh, okay.
Okay?
Still turn it on. It's faster.
Where did you grab it?
She was in there.
So, I mean, when we get to the car, and we keep going? Right. So, we're at the top of the flag. We're not moving anymore. And that's all it is. Okay.
Because like, remember like, people find out, like kind of like,
This goes up and down, up and down, up and down.
I don't really know how to explain. Like, I didn't know how to explain it.
Because the truth is big. It doesn't go up and down, up and down, up and down, up and down.
Oh my Lord, Caroline. Is this one showing you a cleaner version
Right. So,
We go higher. Mine was right
right.
You raise your hand.
Higher. 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 You keep going higher.
My sister higher.
What do you mean?
I'll come get you guys in a second.
Forget about it.
Well, I will.
Oh.
So for it talks about the tree, wouldn't it be like this one since the tree doesn't just go up and down, up and down? Or could it be
It's not wiggly wobbly.
Is it going down?
Yeah.
no, it's wiggling?
Right. What does that tell you?
It's growing.
Well, it's growing because we know it's going up, right? But
So that was also going up.
But let's be. What's happening?
Where?
So at the little spots where it's.
It's taking a break.
It's taking a break. It's
Well, if it was taking a break, it would just be a straight line across, right? So if it's looking like this or this.
Oh, the sun won.
Line is on the tree.
No, the sun won.
You know the tree.
I want to hear it.
What's that?
Growing vine.
No? Nobody.
Mr. Growing.
No roots. So, what's this?
Height.
Height. And it's this. Time. So if I have a vertical line.
So over the years, it's getting taller and taller.
Right. And what I'm getting to is what happens if I just have a vertical line? If it just goes vertical.
It's just straight up.